This video will be the distance between 2 points in coordinate geometry. Okay, so to get started we need to be familiar with the Cartesian plane, and first of all I guess we need to start off with by looking at the x-axis. The x-axis is the horizontal axis, and we also have the y-axis, which is vertical. Now on the Cartesian plane, as mathematicians, we like to plot points, and so we might like to plot a point here and call that A, and we'll also plot a point over here and call that B. Really important that we understand what coordinates mean. Co meaning shared, and ordinate is a number. So if we have a look at the ordinate of x, which needs to come first for A, so we look at A, we find that its x ordinate is 4, and we would write that as 4, and then we need to find the y ordinate, which would be -2. We can find that by reading it off the y-axis. We could do the same for B, and we need to see that we have the x ordinate is -4, and the y ordinate is 3. Also helpful to remember that this is the first quadrant, this is the second quadrant, third quadrant, and the fourth quadrant. Okay, so we've got 2 points here, and we should label them. So we're going to label this one A and this one B. Now what we want to do is we want to find the distance between the point A and B. Now, using the properties of the fact that the y-axis and the x-axis are at right angles to each other, that means that we can create a right-angled triangle here and use that to find the distance between A and B. So we can have one of our shorter sides which comes along the x-axis, and the other shorter side which comes along the y-axis. And this will work for any 2 points that is on a Cartesian plane. All we now need to do is find the distance between of the shorter sides. So for the first one here, we've got 5, and in the y we've got 2. Now because we know Pythagoras' theorem, we can find that, and this length here is going to be AB. We're going to find that AB is equal to the square root of 5 squared plus 2 squared, which equals the square root of 29. So if we leave it as a square root, that's an exact value, and yeah, it's an easy way to do it. However, not every single time that you do this are you going to get that one point is going to lie in the origin, and the origin is where point A is at point 0, 0. And so in this case you can see that we don't actually have any point lying on the origin. We've got 2 random points, but we can use the same process to find the length AB. So assuming that's A and this is B, this is our length AB. We just can use a right angle triangle to find that distance. So we need to go from here all the way over to here to create one of the shorter sides, and then from A straight down to create this one. And here's our right angle, and so we know that AB is in fact our hypotenuse. Now one of the things that you could do is simply count the divisions. So you could count 1, 2, 3, 4, 5. What happens if these points are ridiculously far apart? Well, essentially what we're doing is we're finding the distance along the x-axis, and we're just going to find the difference between 7 and 2. And so we can see B's x ordinate is 7, A's x ordinate is 2. I'm going to subtract the 2 to get 5. And we're going to do the same for the y-ordinates. So we're going to find the distance between the two y-ordinates. And in this case, it's going to be 3 take away -3, which gives us 6, because we add them together. And so, if we were to find AB equals square root of 7 minus 2 squared plus 3 minus 3 squared. And that gives us equals the square root of 5 squared plus 6 squared, which equals the square root of 61. Okay, so points to remember here is that we're finding the difference between the x-ordinates and the difference between the y-ordinates. Right, we need to find this in general form, so we want to find an equation so that we can use it for any 2 points. And so if we have the point A, which we can see in the diagram on the right hand side here, has the points x1, y1. We're just using the subscripts to denote the difference between the 2 points, and we've got B here, which coincides with this point here. Now, the reason why we've used x1 and y1 and x2 and y2 is because this can occur for any value of x1, y1 and x2, y2. Okay, so we're going to now do the exact same thing as what we have done previously, and that's find the sides A and B, which is like the shorter sides in a right angled triangle, and so that we can find the hypotenuse C. And we've shown previously that to find this distance A, we just need to use the difference between the two x values, between the 2 points. And so we have x2 minus x1, which is the distance of the side in the x-plane. So that's our A, and then we've got our B term, which is going to be y2 minus y1, and that's the distance of the side in the y-plane. So that's our B. So now we can write C. So now we can write that D is equal to the square root of x squared minus x1 squared minus y2 minus y1 all squared. And that's something that you need to memorize. Just a quick note, that doesn't matter which points we choose to be x1, y1 or x2, y2. And any example that you want to choose to do, and just swap over which one you choose x1 and y1 to be, swap them around, and you'll find that you get the exact same answer. Okay, so we're given 2 questions here, and remembering that we're going to use the formula, so we need to write that down, and you need to be making sure that you have this formula completely memorized. So the formula is D equals the square root of x2 minus x1 squared plus y2 minus y1 all squared. So the first step to solving this problem is to choose our x1, y1. Really important that we remember that there is always a y-ordinate and an x-ordinate in each point. This is the most likely step where you'll make the mistake. So we've got our x1 and our y1 here. We'll choose this one to be our x2 and our y2 here. It doesn't matter which one you choose, you just need to make sure that you are choosing one to be the x1 and y1, and the other point to be x2 and y2. So the next step that you need to do is substitute that into the equation. We get D is equal to the square root. Now we've got x2, which is 10, and our x1, which is 8, plus our y2, which is minus 5, and we're going to take away 3 from that to get out minus 3 all squared. So simplify that and we get square root of 2 squared plus negative 8 squared. Now we need to remember that negative 8 squared will actually become a positive number because we've got negative 8 times negative 8 and 2 negatives make a positive. So we take the square root, we continue with our square root, we get 4 plus 64, which is equal to the square root of 68. So you could go on to find that as a decimal, but leaving it in its square root as a surd is more accurate. So that's how I'm going to leave it. So question 2, okay, so we need to do the exact same thing. Alright, we need to choose our x1 and our y1, our x2 and our y2. Again, we're going to use our distance formula, so we're going to use that d is equal to the square root of minus 2 take away 6 squared plus, we've got y2 which is 4 minus 3 all squared, which is equal to square root of minus 8 squared plus 7 squared, which gives us square root of 64 plus 49, which equals the square root of 113. In this one we're asked to prove that the triangle KLM is a scalene triangle. Now we've been given the positions of the vertices of that triangle, and so what we now need to do is prove that it is a scalene triangle. So first of all we need to think about how do we know if a triangle is a scalene triangle? Well, we need to remember that a scalene triangle has sides of different lengths. So in order for it to be a proof though, these are the things that we need. Alright, so there's 3 things that we need to do in order to prove that the shape KLM is a scalene triangle. First thing is we need to find the lengths of each side. So that's what we need to do now, is we need to find the lengths of each side. So we need to find the length KL, which is equal to the square root. Now we need to, let's choose our K to be x1, x2, y2. So we're going to use K is going to be 1 minus, and we're looking at L, 1 minus 7 all squared, plus we're going to have 6 minus 4, and when you put that onto the calculator you're going to get that it is 7.21. Alright, now we need to find the length KM, and so we're going to do the square root of 1 minus, and so looking at the mx ordinate, 1 minus 3 squared plus, we've got 6 minus 4 all squared, which equals 10.12. And finally we need to show that LM and find the distance of that. So let's choose L to be our x2, y2, so it's going to be 7 minus 3 squared plus 4 minus 4 squared equals, which equals 8.94. Okay, so we can see that all the sides aren't equal, so we need to show that they're not equal. And the way that we show that they're not equal is by simply doing, so this is step 2. So step 2, we're going to write that KL does not equal Km, which does not equal Lm. So we can see that all of the sides aren't equal. So then we need to write our final statement. All sides are not equal. Therefore, we can use this. Remember, we've used this before. Therefore, KLM is scalene.